Mirror, mirror on the wall, who is the grippiest of them all? If there's one thing that's important in 3D printing, it's getting solid bed adhesion and a picture-perfect first layer. It's the difference between a reliable 3D printing experience and, well, this. But bed adhesion is a topic of somewhat heated debate. We've got the dish soap devotees, the alcohol advocates, the glue stick geeks, the Magigoo messiahs, 3D lac legends, and of course, as with so many things in 3D printing and life in general, every single camp is absolutely sure that their chosen solution is objectively the best. But which one actually is? In this video, we set out to scientifically test and find out. We'll be testing the top 10 most popular bed adhesive solutions across the 5 most popular 3D printing filament types to see which one reigns supreme. And since I'm not exactly known for my, shall we say, scientific rigor, at the end of this video, I'll be submitting my work to fellow content creator and die-hard 3D printing tester, Dr. Igor Gaspar from MyTechFun, to see which score he gives it. Preheat your seats and let's get after it. First, my testing methodology, and do feel free to use the chapters below to skip ahead if you don't care about this part. So throughout this test, I'm going to be testing a wide range of 3D printing adhesives that you can see here against 5 different materials. And no, I'm not just going to test them once for an ideal world strength comparison, as in the strength of the first print immediately after application. Actually, I'm planning to test each of them 10 times, printing the samples in the exact same area of the bed each and every time to try and chart how well they score on longevity. This is important because, as many of you commented on my recent video where I talked about Magigoo, some of these adhesives are a bit pricey, but that would be easily offset if you only needed to apply them like 1/10 as frequently. Not only because it means that you would use 1/10 as much material, but also because your time and effort are worth something too. It is, however, a proper ton of testing. So let's talk a little bit about the test sample. For this experiment, I went ahead and designed a part specifically to test bed adhesion. It features sharp corners that are notoriously difficult with warping and a known surface area to make calculations easier. In this case, it's 100 millimeters squared. And of course, I designed it to be as easy as possible to connect my load cell so that measuring would be easy. After all, I am planning to conduct around 600 individual tests. By the way, I am aware that this design has some limitations and that some of the materials will warp more as you progress throughout the print, but this is how I'm doing it, and if you don't like it, you're more than welcome to test your own 600 samples. Or just comment below that you'd like to see a follow-up video. I'm sorry. Now, to actually do the tests, I'm gonna go ahead and print everything except for PLA on the Prusa XL, which Prusa was kind enough to send over for the purposes of this video. Now, I think this is going to make my job a whole lot easier because I can just lay out all the different samples of most of the materials and then let the printer do all the work of actually laying out and printing the different samples. And all I have to come in and do is test all the samples for each round all at once. I also chose the XL because it has Prusa's perfect first layer technology, which will eliminate that whole variable of variances in the Z offset at different points in the bed, which could easily throw our data off completely. Unfortunately, despite having the ability to selectively heat the bed only in the areas you need, the XL does not have the ability to heat different areas to different temperatures, which means that I will need to pick one temperature for all of them and stick with it, which is why I noted that I'm going to print PLA separately on the Mark IV's. As for which temperature that is, I'm going to go with 105 Celsius, which admittedly is a little bit high for everything except nylon, especially PETG, but I hypothesize that higher temperatures won't negatively impact strength of adhesion nearly as much as, say, trying to print ASA or nylon at 85C to accommodate the PETG. Now, to actually gather the data, I will be pausing the print at the very end and testing each sample while the build plate is still hot. Yes, I know that some of these adhesives feature the ability to automatically release when the build plate has cooled, but that's not really what we're testing here, and it's kind of a nice to have compared to the ability to actually complete your prints without them detaching from the build plate. I also went back and forth on whether I should print these samples enclosed or unenclosed, and ultimately I decided that I really just wanted to challenge these materials as much as possible. So I actually went ahead and printed all of these materials unenclosed, including nylon, of course, in a well-ventilated area. And finally, a word on print profiles. I am going to be using the default recommended temperatures and profiles for each of these filaments in Prusa Slicer, as I kind of trust that if anyone out there has the perfect profiles for these materials, it's going to be Prusa. Now, let's meet our contenders. Now, you might be asking, why no ABS slurry or dissolved glue stick or magic fairy dust that your grandma makes? Well, in this video, I wanted to only test the commercially available solutions. And unfortunately, as far as commercial solutions go, Vision Miner was not able to ship to Israel in time for this video, which really bummed me out. But yeah, we can only test the materials that we have, right? By the way, just a quick ethical heads up, all of the products in this video were provided to me free of charge for testing. None of these companies sponsored this video or will see any of it or any of my results before any of you do, but I do need to point out that the company that makes Magigoo has sponsored a video in the past, and they recently began supporting the channel monetarily on an ongoing basis. So there is some inherent unavoidable bias towards their product. With all that said, I was a huge fan of the product before they ever sponsored us, and I also did my best throughout the testing just to not let my personal biases influence my data or my results. Or in the case of things that are subjective, like appearance, I try to deliberately point out when I caught myself being biased towards one product or another. And now, let's get to testing. Okay guys, we're at round 5 right now, and as you can see, the wheels have kind of come off this experiment. Some of the materials are completely not working. I'm not quick enough to cancel objects, so it's throwing off the other results. My tape has actually just become detached and embedded into some of the prints, which I'm sure is throwing things off. And on top of all of that, some of the adhesives were still so strong that when I lifted them up, the entire bed lifted and shifted, which throws off the results a little bit. This isn't what I wanted. I wanted to get to 10 tests, but why don't we transition over to looking at the data we have so far and see if we at least have a trend of statistical kind of worthiness and see what we've learned so far about these. And then I guess maybe if I have to, I'll try and salvage this. I definitely can't redo 5 up to this point to then start from this point again to get to 10. But here you can see we have to cancel that object, and I'm just not quick enough to cancel the object. Anyway, let's transition over to looking at the data and see if this data makes sense at all to begin with. All right, we're going to get into the actual testing data in just a second here, but before we do, I do need to take a moment to thank this video's sponsor, which is 3D Fuel. 3D Fuel is a US-based filament manufacturer with US supply chain and US customer support that makes easy to use and highly functional 3D printing filaments. Their products include Pro PCTG, which is up to 20 times tougher than PETG, my arch nemesis, and has better chemical resistance and 1/3 slower moisture absorption, as if I needed any reason to switch from PETG. They also offer Tough Pro PLA Plus, which is up to 9 times tougher than standard PLA. It's super easy to print and available in 40 colors and counting. Oh, and they even have 3D Clean, which is great for cleaning your hot end and purging out high temp or CF filaments. Now, I've been printing a bunch of 3D fuel around the studio for some upcoming projects that you're gonna wanna stay tuned for, and so far it has definitely lived up to the claims. So to pick up some 3D fuel yourself, visit the link in the description. All right, let's get into some testing data, shall we? Hey, welcome back to the home office. So I haven't looked at this data yet myself, and I want to look at it together, all of us, and analyze it together. So what I did is, as with the last video, if you haven't checked that out, make sure to check it out, where I tested drying strength against each material. For this one, I just did all the data, laid it out in each line item. You can see here we've got raw dog, generic glue stick, purple glue stick, and so on, which material I was testing, which trial number it was, how much force. Then we have the force in kilos, the force in Newton meters, and the force in megapascals. And I will publish this entire spreadsheet. It's already available to my Patreon supporters and my YouTube members. But then we went ahead and made a series of pivot tables, ChatGPT and I, to try and get different comparisons out of this data. So the first one that I want to look at is, what is the strongest adhesive by material? As in, if you're going to be printing ABS, or if you mostly print PLA, or if you mostly print PETG, which one is the best for you? In a minute, we will get to what is the best all-arounder if you're only going to buy one of these products. But right now, let's talk about, okay, I mostly print ABS. Which one should I use? And you'll see here, I have them all by the color of their brand or packaging to help make it easier. And we'll just go through it. So for ABS, 3D Lac was the winner. Magigoo was a close second, so this might be a rounding error. But these two dedicated products that are meant for printing plastics, not kids' crafts, definitely outperformed the others, and even just the raw dog using the PEI sheet dramatically. There were improvements with purple glue stick and regular glue stick over nothing, so those are still worthwhile. But if you're mostly printing ABS, you want to look into one of these two products. For ASA, it lived up to its reputation, at least around my studio, of being really hard to get to stick to the bed. You can see it's so much harder to get it to stick to the bed than ABS. And I will say ASA, I think, was thrown off a little bit by the fact that 1 or 2 samples failed, and then they caused all the others to fail. So my numbers are not as strong for ASA as they might have been for other materials, and I might have had some error in my data there. For ASA, actually, generic glue stick performed admirably. 3D Lac was the second best, right above just going straight on the PEI build sheet, which I found surprising. I've had great experiences with Magigoo. This video isn't sponsored by them, but Magigoo really helps me. But I don't use the generic, I use the specific one. And I will say, I think I got confused and I used the wrong one. They say with ASA, you should be using, I think, the PC one, and I might have used the PA or the other way around, because it shocked me how poorly it performed compared to my general experience. So for ASA, I would say generic glue stick is pretty darn effective, followed by 3D Lac. If I were redoing this, I would try the other specialized Magigoo, because that one I've had a lot of luck with. And again, it could also be that it was right next to another one on the build plate that didn't perform, and then the stringing or failed part knocked the others off. So that was a little bit of an issue in my experimental design. For nylon, Magigoo, their specific formula for nylon, performed far and away better than everything else. If you're printing nylon, you want to be using Magigoo. What was surprising to me is the 3D Lac generic, also for nylon, maybe again because of where it was on the build plate next to Bamboo's glue stick, did not perform as well as I thought it would. But 3D print stick performed okay. But yeah, if you're printing nylon, Magigoo is going to be your best bet. And the purple glue stick did live up to what the manufacturer who had sent it to me, the manufacturer of the nylon who sent it to me, they said our product works best with purple glue stick. They weren't wrong. It's much better than other glue sticks, particularly Bamboo's glue stick, liquid glue stick. So yeah, for PETG, no surprises here. Everything sticks pretty well to PETG. I guess the only surprising thing was Bamboo's glue stick did not perform very well. Honestly, if you're printing PETG, yeah, probably just the PEI build plate is enough for you. If you want a little bit better, Magigoo's also good, but 3D print stick really performed better than everything else. I think it was clear to me at this point, because 3D print stick did not perform, as you can see, on pretty much any other material. It was clear to me that this product has been formulated for people who mostly print PETG. And up until I looked at the PETG results, I was like, what is this product good for? To be honest, sorry guys. 3D Lac also performed really, really well. So yeah, just if you're printing PETG, you want to either use the PEI sheet or use 3D print stick, 3D Lac. Magigoo will give you a little bit of an advantage as well. For PLA, I had some weird issues with the raw dog. I think it was too far on the edge of the plate and I had not properly cleaned all the dish soap off. So raw dog was thrown off big time and I was very surprised by that. But for PLA, you can really see why some people swear by glue stick. They're not wrong. Glue sticks, whether it was Bamboo's glue stick, generic glue stick, or purple glue stick, those outperform everything for PLA. They're not wrong. They're just mostly printing PLA. And if you're just printing PLA or just printing PLA and PETG, you probably don't need a fancy dedicated adhesive designed for 3D printing. And that's why I think there's so much disagreement in the comments. We're all just printing different things. And can't we all just learn to get along and see one another's point of view? Now, in a second, we're going to look at the overall winner, which was the strongest across the board, across trials, across materials. But first, I do want to look at the strength over time, because one of the huge benefits or value propositions of these products is that you apply them less, they last longer, it takes less effort, less material. And I wanted to test that out. So here we have a pivot table, which is going to show us each material, each adhesive, and how many trials and the strength, and we can chart that. And so looking at PLA, you can see pretty consistent, again, for the glue stick. There are, as I said, some instances where data was affected by one failing and then the others next to it failing. I'll also admit there were definitely some instances where I didn't get the hook in correctly with the load cell and I knocked off the sample. So this data wasn't perfect. And like I said, the wheels definitely came off this experiment at a certain point. So you can see that on the graph, right? If you look at generic glue stick number 2, I knocked it off. I had a 0 value. It didn't stick. And it's pretty actually clear to see where that failed. Like I said, for raw dog, I had some weird situation where I think the build plate wasn't clean. I didn't move the soap off well enough or remove the soap well enough, and it just didn't stick, which is unfortunate and really kind of ruins my data, because I would have liked to know if, for example, the glue stick was the same as the raw dog, and you can see they're almost exactly the same at the second trial. So PLA, not the best data overall. But you can see some of these materials, or adhesives I should say, do stick around for a while, and some of them even improve over time with repeated use. You can see an upward trend on the 4th and 5th trial of these specialized adhesives, Magigoo and 3D Lac, and the same is true just generally. You can see better bed adhesion as we go. Is that because of the way I was testing? Is that because of some other factors, such as the temperature in the room between the 2 different days? I'm not sure. But let's go ahead and look at PETG. PETG, you'll remember, was pretty strong all around. Something weird happened in the 4th trial. I think I didn't log my data correctly, so I apologize for that. But you can see PETG kind of all over the place. It really does seem to depend on something else, and I don't think we can actually draw effective conclusions for that. But our conclusion in the past was everything kind of sticks pretty well to PETG, so I'm not too miffed about that. I now want to look at ABS and see over time, how does that work? And again, something really weird happened with number 4, and I'm not sure why. But you can see that these specialized materials, they do last for a while. There's not a drop-off between trial 1 and trial 2 and trial 3, as there is with the glue sticks, which start to work less and less, but actually they're increasing as they burn in, kind of. They're actually getting better and stronger. And I think probably if we were to chart this correctly and something hadn't gone wrong in trial number 4, I need to look into why the data is wrong, we would see that. Let's now look at ASA, and we can see this one is all over the place. As I said, it was next to nylon, so I don't think we can read too much into this data, unfortunately. Both ASA and PETG, I'm embarrassed to say, I don't think I got good enough data. And for nylon, we're kind of seeing a similar thing. Not great data, unfortunately, between the trials, but we can see that there is a kind of upward trend here in the 3D lac and in the specific Magigoo. So I think that that is showing us that they do last longer than these other ones, which after 2 trials, 2 attempts or 2 prints in the same exact area, you do see kind of some of these other ones like the bamboo glue stick dropping off. But now, after that slight disappointment that we didn't get the data as clear as I wanted it, I'm sorry guys, let's look at the overall strength, right? What is the winner across the categories? What's the best all-around product if you're only going to buy one based on my information here? If you're only going to buy one of these and you want it to work with everything, you guys were right. Actually, 3D lac was the best all around for everything. When you take it across 5 different trials with 5 different materials, 3D lac was the best all arounder, I will admit. And they don't ship worldwide, so that's a little bit unfortunate, but they're apparently working on that. And Magigoo was a reasonably close second. Magigoo's generic product worked pretty well. They do ship worldwide, and there's free shipping on Amazon. So if you can't get 3D lac, Magigoo is a pretty close second, right? We're talking 3 newtons off on average. And then, honestly, for all around, you're actually better off with just a PEI build sheet than you are with most of the other glue sticks. Again, it varies, right? So look at the previous chapter. You can skip back and see some materials benefit a lot from glue stick, but other ones, you're actually better off with the PEI sheet. And that's not even to mention the artifacts that the glue stick leave on your print. It's not even to mention the stickiness and the nastiness and needing to wash it. So yeah, I've been anti-glue stick for a while, and I admit maybe my data is biased as a result, but glue stick, depending on the material, you may just be better off cleaning your build plate correctly. As far as glue sticks go, purple glue stick does seem to be slightly better than generic glue stick, which seems to be slightly better than bamboo glue stick. Bamboo's glue stick performed really, really well for some materials, but for others, the average was brought down so much. 3D lac's specific product actually disappointed a little bit when it comes to nylon. So there you go. There's the data. 3D lac is the winner. Magigoo is second place, and just standard PEI is actually third place. So there you go, glue stick people. Now, I mentioned before in passing, but I think it is worth stating again that adhesion strength is not the only thing that matters here, especially because after a certain threshold where the print stays attached, I mean, more strength doesn't necessarily matter above and beyond that. But 2 things that definitely will matter are print quality and your quality of life. Now, I've long been camp anti-glue stick because of both the sticky, nasty residue that it leaves on prints, as well as the scars it can often leave on the surface of your prints. So to demonstrate this, I once again applied a thin line of each adhesive across the rows on the build plate, and I took advantage of Prusa's Perfect First Layer tech to show the differences between the dedicated products, which come with a special applicator tip to dispense a very small amount of the product, versus the generics like glue stick, which can often glob on. So let's go ahead and take a close-up as I peel this away, and we can check out the differences, if there are any, together. You can see here the liquid glue leaves this peelable residue, really nasty, which comes off on all your prints, hopefully, but also sometimes just gets embedded in your print. So that's the liquid glue. You can see generic glue stick, again, leaves this residue, which is, if you wet your finger, sticky and disgusting. But then even once you remove it, you're gonna have some scars in your print. Not as bad as I thought, honestly. you can just barely make out where there are scars. The bamboo glue stick, wow, look at that. If you remove that, you can see here, that leaves a scar on your print. But again, not as bad as I thought. There is a little bit of a scar, but you still get the texture of the build plate. So it's not nearly as bad, but you can definitely see here, there is some scarring. Although that seems to be from 3D lac, so that may be adhesive from something else. Here we have just a legit piece of glue stuck in the print. I have to say, the scarring is not nearly as bad as I thought it was going to be. But if you look at the dedicated ones, ignore this line. This is adhesive that was stuck from the tape. If you look at the dedicated ones, those ones are actually sticky too. They do actually have a sticky residue. I'm surprised. I may have exaggerated or just been biased. The Magigoo also has a sticky residue. There's no denying that you have to do less cleaning with the dedicated ones, such as the Magigoo and the 3D lac. The texture looks better, and we just don't have all this peelable residue or this stuff that you need to wash off. But yeah, it's not as big of a deal as I thought it was. The 3D print stick is not sticky at all. The purple glue stick looks pretty good, but you can definitely still see some marks. But overall, I think the scarring is not as bad as I had made it out to be. And yes, by the way, it's worth pointing out that the Magigoo specific nylon actually damaged the build plate. It's that strong. You should not remove it while the build plate is still hot. It just ripped off a piece of the build plate, which is why we are seeing that scar here. But otherwise, you know what? The differences are not as bad. I'll bring it up close and I'll let you guys be the judge in terms of the scarring. But the differences are not as bad between the dedicated and the generic adhesives as I thought they would be, but definitely more sticky residue on the generics, though none of them are free from stickiness. Interesting. Additionally, I will say that I find some of these products much easier to use than others. Like anything with one of these cloth applicators that I talked about before, I find much easier to apply evenly without the globs or boogers, whereas even the dedicated adhesives, if they just come in a normal squirt bottle like this, are kind of a pain in the butt to get a thin layer. For the purposes of this video and for being able to separate the different adhesives on the build plate, I didn't use any of the sprayable options that are out there on the market, such as hairspray or 3D lac's spray version, but those are also a great option for getting a thin, even layer on the build plate. And I think quality of life and ease of use are just as important as print quality and possibly even as important as adhesion. But now, I've put it off for as long as I possibly can. We now need to present our work to Dr. Igor Gaspar of My Tech Fund, errors and all, and see what he has to say. Now, because Igor is such a busy man and, unlike me, has a real day job doing actual engineering, he did ask that I submit all of my work and my results and methodology to him asynchronously so that he could carefully scrutinize it after business hours. And I'll admit, this made me a bit nervous. After all, it would give me little to no opportunity to use my personality and charm to overcompensate for my scientific shortcomings. But after reviewing everything I sent over, here's what Igor had to say. Let's have a look.
Okay, Jonathan, I analyzed your work. Let's talk about the testing method. First, I thought that the testing some more practical situation is better. For example, where the nozzle hits the object if it has a curling up. But actually, if you fight against the warping, in that case, your testing method is good, where the pulling force is perpendicular to the print surface. Of course, in this case, you need a bigger force, and be careful, stop above some value to avoid damaging of the build surface. Now about the evaluation of the data, always give the units on the graph, and also don't forget to give all the data necessary to reproduce the experiment if somebody wants to do this. About the table for your pattern supporters, be careful with the units because only the first one is the force unit, the Newton, the second is the mass in kilograms, and the third and fourth probably wants to be force applied to some surface or area. In that case, the unit is Newton per square millimeters or megapascals and not Newton per meters. That's something completely different. So overall, this is very useful information and I will use it myself. So I'll give you a grade C.
And honestly, with the sheer amount of issues that I had collecting data, screwing up my measurements, and much, much more, I can't say that's not fair. But let me know in the comments below what you think. I mean, what grade would you have given me on my work in this video? So what did we learn and what conclusions can we draw from all of this, if any? Well, if you live in Europe, 3D LAC is just a fantastic product all around. For me, living in Israel, or for those of you living in the US, Magigoo is a close second. But if I weren't printing such a wide range of materials all the time, I'd probably feel the same way that many of you in my comments section seem to feel. A clean PEI build plate with some solid dish soap is generally good enough. Maybe with some glue stick on occasion for printing more exotic materials or as a release agent. Oh, and also, contrary to what some people online might have you believe, no, these dedicated adhesives are not just dissolved glue stick. They actually are significantly better than just your normal glue stick or probably hairspray. But again, here I'd love to know what all of you think, and I'd love to get a discussion going in the comments and hear what your experience has been and if it matched up with my test results. And maybe, just maybe, we can all find some common ground and put an end to the great bed adhesive war of the 2020s. I'd once again like to thank Dr. Igor for his time and for playing along with my gag. As with my last video, this one really taught me just how much work folks like Igor, Stefan, and James from Cloud42 put into doing this type of research for all of us to enjoy. So please make sure to support them if you enjoy this type of research. Personally, I have to be honest and say that I don't think I'll be doing many more videos like this in the near future. Not only am I clearly not that good at it, but I don't really enjoy them nearly as much as other creators seem to. And I don't find them as creatively fulfilling for me as working on projects. So if you too like to see creative projects, fun 3D prints, printer builds, and so on, get subscribed because there's definitely more of that coming in 2025. That's all for this week, but I'll see all of you on the next layer.